Hi Geometry, this is Unit 3, Lesson 3 Notes, and I'm on page 325 of our workbook. So we are to dilate triangle FGH using center C and a scale factor of 3. So my K is 3. I know this is going to be an enlargement. It means the image I'm going to draw is going to be 3 times bigger than my original, and everything's going to grow from C. So C is going to stay fixed, but G prime, F prime, and H prime will grow away from C, and the triangle will be, my new image triangle will be 3 times bigger than my original. So let's get started. First of all, you can use a ruler or you can use a compass for an enlargement. I'm going to be using the compass. So for me, I use a compass anytime my K is 2, or my K is 3, or my K is 4, or basically any number greater than 1 that is a whole number. The compass just goes very quickly compared to measuring. So, and you'll look at both ways. So let's do this. Let's first focus on F. So I want to find out where F prime is. So I find the distance between F and my center. And F prime will be 3 times this distance from C. So what I see here is really my first distance. So let's go to F and put my pointer on F. And I'm going to arc off my second distance away from C. And now where that arc is, put your pointer and arc one more time. That's my third distance. So notice I made 2 arcs and I found my F prime, which is 3 times further from C than F was. So let's do it again. I'm going to measure from C to G, and then I'm going to put my pointer on G, and I'm going to measure that distance again a second time. That's 2 times farther from C, and I'm going to do it a third time. So that would be my 3 times farther. So I have a distance 1, 2, 3 times farther from C, and that's where G prime is. So then now let's do H. So I measure how far H is from my center, and I mark it once, and then I mark it twice. And now this is really 3 times further from C, and this is my H prime. Notice the common mistake kids make in the very beginning is they will measure the distance, and then since the K is 3, they'll start at H and make 3 arcs. But when you do that, you're really creating a distance of 1, 2, 3, 4 times further away from C. So really, if you made 3 arcs to get your H prime, you'd really be doing a K of 4. You'd be 4 times the distance away from C. You've always got to count this first one that was already there. So I only want to arc twice. So grab your straight edge and connect your G prime and H prime and your F prime to create your image. So the purple triangle is my image. And we say that triangle GHF, my original, is similar to triangle G prime, H prime, F prime. And in geometry notation, that's a tilde. So I can write triangle GHF, little tilde, single by itself, nothing else with it, triangle G prime, H prime, F prime. This means similar in geometry. They're not equal, they're not congruent, they are similar. And my scale factor, which we already knew, but my scale factor is my image over my original. And you guys already knew that it was 3. So really, if you think about this distance of being 3 and my original distance as being 1, it's really 3 over 1, or 3. And we knew that when we got started. Sometimes we have to find the scale factor, sometimes we're given the scale factor. So what is there to notice here? There are so many things to notice. So what are some stuff that we should notice? So remember, my scale factor was 3. We just talked about it. So triangle H prime, G prime, F prime. Notice I put it in a different order because order doesn't matter when you write the first one. So is 3 times bigger the sides are going to be 3 times bigger than, and now when I write the second one, I'm going to match them up. So I'm going to call it HGF. And I know that the side HG, H prime, G prime. So let's go find it. It's this purple side right here. I know that's 3 times bigger than HG. I don't really know the distance at the moment. I'd have to measure it. But whatever this is, I know this is 3 times bigger. Or you could think in reverse. 1/3 of H prime G prime will be equal to HG. And that's true about all 3 sets of sides. So let's just fill that in then. H prime F prime is 3 times bigger than the original HF. Or I could think of the big one is 1/3 of the original. Oh, sorry, that was supposed to be an F, my bad. And HF. And then finally, let's do GF. So G prime F prime is 3 times bigger than my original GF. Or I could think of the big one being 1/3 as big, G prime F prime, as my original GF. You can write G and F in either order, but once you write it one way on the left side, please write it the same way on the other side. So this is telling me an important thing. We say the sides are in proportion, and you've seen that in an earlier lesson, because they all relate. Either you can think of the big one being 3 times bigger than the original, or you can think of 1/3 of the big one is equal to the original. And so the second thing that's important to note is that the angles are congruent. So corresponding angles are congruent here. So I know that angle G is congruent to angle G prime. I know that angle F is congruent to angle F prime. And I know angle H is congruent to angle H prime. Okay. So let's take it, and this is something we learned in an earlier lesson about similar figures. The sides are in proportion and the angles are congruent. So let's go to the next page, page 326. So on page 326, we have a figure that we're going to be dilating. And you and I are going to dilate this 2 different ways. We're going to dilate this with a K that's 2 and a K that's 1/2. So let's do the 2 first, since that's the one that we, and I'm basically, let me show you where I'm going to go with our notes. I'm basically going to be doing on my page, I'm going to have this entire right side is going to be information about K being 2. And then the entire left side is going to be information about K, my scale factor being 1/2. Notice when my K is smaller than 1, my triangle gets littler than the original. And when my K is greater than 1, my triangle gets larger than the original. So these are the way I'm going to set our notes up in our video as well. So right now I'm going to be writing on the right side of my page, and this is going to be for K equals 2. You can use your compass or your ruler to do this. I'm going to use my compass. I tend to do that for all my K's that are whole numbers greater than 1. Sorry about the focus. Let's see if this will focus in for me. There it comes back. Oh, good. Okay, so be sure when we do this, when we get ready to do this with our compass, be sure to only mark 1 more time for 2 total. Let me show you what I mean. This is the mistake I said kids make on the other page. So let's grab a straight edge. We're going to start at my center C, and we're going to draw through all 3 vertices. So I'm going to start at C, F, and I'm going to lightly draw through them, really lightly, because this isn't part of my answer at all. It's just a line that I need. And then let's lightly draw through G, and let's lightly draw through E. Very lightly. You could even use your pencil to do that. So these lines are what my triangle is going to dilate along from my center C. So I'm going to measure the distance from F to C. And now F prime is going to be 2 times this distance from C. So I'm only going to mark it one more time. And when I do that, I have a distance that's twice as far. So this is my F prime. Be careful, I mentioned before in the last activity, when K is 2, some students like to measure and then mark once, twice, because the K is 2. But if you do that, you really have 1, 2, 3 times the distance away from the center. So be careful with that. We're gonna mark only one more time. So now let's go measure to G. And I'm going to mark one more time. And let's measure to E. And I'm going to mark one more time. Awesome. So let's mark this as my G prime. I'm going to mark this as my E prime. And I'm going to grab my straight edge because we don't ever just freehand connect my points. And I'm going to connect my 3 vertices of my triangle. And I'm going to lightly shade it in. And in this picture, I know that this new triangle is an enlargement, and it's similar to my original. So triangle, we can call my original anything. Let's call it EFG, is similar to triangle E prime, F prime, G prime. They're similar to each other. This was an enlargement because my K was greater than 1. And so my image is bigger than my original. Everything about it is twice as big. So it says measure the sides of EFG to the nearest millimeter, and that's my original. So let's take a moment and measure the sides of this. So from E to F, I'm going to line up my ruler or protractor. So don't use your inches. Don't use inches. Our book likes to use the millimeters. So when I measure, whether I'm using my ruler or my protractor, this is really centimeters. But remember, the metric system goes by 10. So when I line up F to E, this right here, FE, looks like it's almost 3, but it's not. It's at the tick mark right in front of it. So it's like 2 and 9 tick marks. So that is 29 millimeters. This is 30 millimeters, 3 centimeters. This is 2 centimeters, 20 millimeters. So if I'm 2 and 1, 2, 3, 4, 5, 6, 7, 8, 9 tick marks, I'm at 29 millimeters. 2.9 centimeters or 29 millimeters. So EF equals 29 millimeters. I'm going to put an approximate symbol here instead of an equal sign. I am measuring this. If you do equals, it's fine, but I'm going to use 2 tildes, and that's approximate. This is the approximate symbol. And we can sometimes use that instead of an equal sign to feel more accurate. So let's measure FG. And I think I have the same situation. It looks like it's the tick mark right in front of the 3, which is 2 and 9 tick marks, so 2.9 centimeters or 29 millimeters. So FG is approximately 29 millimeters. And let's go find EG. So EG looks to me like it's at 1 centimeter and a half. So 1.5 centimeters, or multiply that by 10, 15 millimeters. So EG looks like it's approximately 15 millimeters. This is my original. This is my original black EFG that's on my paper. So then let's divide the next part in half. It says that your teacher will assign you a scale factor. I did. Right now we're doing our K equals 2 scale factor. It says predict the lengths of the original and the image after you dilate your scale factor. So my dilation then, I'm going to be predicting for K equals 2, what do I think E prime F prime will be? What do I think F prime side F prime G prime will be? And what do I think E prime G prime will be? Well, if I've done this accurately, my sides should be in proportion. Remember, your sides will be in proportion. So since my scale factor is 2, my new side should all be twice as big as the original. So this should be 2 times, let's go find what EF was, approximately 29 millimeters. I'm going to use approximate symbols again, but equal signs are fine. Doesn't make your answer wrong at all. FG was 29. So my, oh, this is a single prime. I'm sorry about that. This is a single prime. My purple one is the one I labeled with single primes. So this would be 2 times 29. And then finally, E prime, G prime would be 2 times 15. So this would be approximately 58 millimeters. This should be approximately 58 millimeters. And this should be approximately 30 millimeters. Why don't we go measure and see how we did? So I'm going to go see if E prime, F prime is approximately 58 millimeters. So when I line up F and I line up E, I'm at 5 centimeters. And it certainly looks like I could be, there's the half mark, 1, 2, 3. It certainly looks like I could be at 5.8 centimeters, which is 58 millimeters. And you can check your other sides. So now let's do the other side of my paper. I'm going to use green for my K equals 1/2. So let's do this all over again. But this time my scale factor is going to be K equals 1/2. And this, I know, this I'm definitely going to use a ruler. I'm not going to be able to use my compass. So this is the first time you and I have done this. And this is going to be a reduction because my K is something between 0 and 1. So I know it's going to get smaller. So in this, and when I do this, my step 1 is to draw my lines CF, CE, and CG if I haven't. And then to measure, I'm going to measure CF, and then I'm going to divide by 2 and mark F prime. Then I'm going to measure CG. I'm going to divide that by 2, and then that helps me mark G prime. Then I'm going to measure CE. I'm going to divide by 2, and then I'm going to mark E prime. So let's do that now. So I'm going to measure CF. It looks to me like it's exactly 2 centimeters, which is 20 millimeters. So halfway would only be 1 centimeter or 10 millimeters. So this would be my F double prime, we'll call it. Oh, can you go up here and change these all to double primes? Thank you, I appreciate that. So my smaller figure will be the one with double primes in the video notes. So now we're gonna measure CG, and it looks like it's exactly 3 centimeters. So half, that's like 30 millimeters. So half that would be 1.5 centimeters or 15 millimeters. So let's go 1 and then halfway. Looks like my G prime, it's about right there, G double prime. Sorry about that, G double prime. And then let's measure my CE. CE, again, looks like it's exactly 2 centimeters, which is 20 millimeters. So halfway would be 1 centimeter or 10 millimeters. And so this looks like it's going to be my E double prime. And I'm going to connect my F double prime, my E double prime, and my G double prime. And then I'm going to lightly shade it in. And I know that triangle F double prime, G double prime, E double prime is similar to triangle FGE because they are, it's a dilation, and so they're not congruent, they are similar. So now let's do what I predict my sides are going to be. So this is for when K is 1/2. My sides should all be half the length of the original. So E double prime, F double prime should be approximately 1/2 of my original 29 centimeters. My F double prime, G double prime should be approximately 1/2 my original 29 millimeters, and my E double prime, G double prime should be exactly half of my original 15 millimeters. So this looks like this should be approximately, what is that, 14.5 millimeters, 14.5 millimeters, and this is 7.5 millimeters. So let's go see if it does look like E prime F prime is around 14.5 millimeters. So E prime F prime, or a double prime. So when I come up here, it does look like to me, this is 1, and it does look like I'm 1, 2, 3, does look like I could be 4 tick marks. So that is 1.4 centimeters or 14 millimeters. Do I think I'm 14.5? Sure. This is where my 5 is. Am I somewhere right near there? Yeah, I think so. For accuracy purposes, it looks like that is very close to what I have on my paper. So then 2 other pieces of information I want you to note, you guys. Up here, please notice, and I'm going to put it in, well, this is supposed to be blue, so it looks different. But I'd like you to notice that the sides are parallel. So what do I mean by that? Please notice that it looks like, let's take a look at E double prime, G double prime. It looks to be parallel to EG, which looks to be parallel to E prime, G prime, the larger one. So I could do the same thing with my other sides. As they grow away from C, it looks like they're parallel to each other. That's because we're going to learn in a future lesson that dilations take lines to parallel lines. So this is all dilated from C, and they would be parallel to each other. The other thing I want to make sure that we're keeping in mind, that my sides are in proportion. So let me grab my green one again. Remember, my sides are in proportion by my scale factor. It depends on what my scale factor is. But my angles, my corresponding angles are congruent. So up here, ladies and gentlemen, I know angles are congruent. So I know that angle F is congruent to angle F prime, which is going to be congruent to angle F double prime. And I could do that for all 3 of my angles in the picture. So this page right here is just an extra practice page. You could try all of these things again on your own. You could use different scale factors and come to extended learning, and we could check it out together and see how you did. So this is an extra practice page for you. I'm going to end this video here. I will make a second video going over activity 3.3, using this to talk about the measures of our sides. Thank you very much.